Okay, I have a question over here. Question number 10. A missile weighing 400 Newton on the Earth's surface is shot into the atmosphere to an altitude of 6.40 times 10 raised to the power of 6 meter, taking the Earth as a sphere of radius 6.4 times 10 raised to the power of 6 meter, and assuming inverse square law of universal gravitation. What will be the weight of the missile at the altitude? Hmm. I wanted to say this question is very simple, but I don't want some people to feel very, very offended. But let's bring out the parameters. This is under what? Gravitational what? Field. Let's bring out the parameters. So, from what we have here, we have the missile weighing 400 Newton on the Earth's surface. So, on the Earth's surface, on Earth's surface, on Earth's surface, the missile is weighing what? 400 Newton, okay, into the atmosphere of altitude. So we have atmosphere of altitude. Let's say that is above the what? Above the ground. That means height above the ground. Altitude is also height. If you're in my previous class, you know what I'm talking about. Height above the ground as what? 6.40 times 10 raised to the power of 6 meter. Taking the radius of the earth is the same thing. Times 10 raised to the power of 6 meter. Then the question says, what will be the weight of the missile at the altitude? So we are looking for what will be the weight of the missile at the what? Altitude. So we're giving the weight of the missile. The weight of the missile on the Earth's surface. On the Earth's surface as 400. We are looking for the weight of the missile at the what? Altitude. That means at this height. What will be the weight of the missile above the ground at this level? So let's say, let me call this one F naught for what? Weight on the what? Earth surface, while we call this F. So this is what we are looking for. Now, there are many ways to do this. But I guess there's the formula to do this is going to be F equals to what? F naught over what? D R raised to the power of what? 2. Now this is the what? The formula to solve for this question. To solve this question, this is the actual formula for what? The weight at the what? The altitude. Now, how come about this formula? And when do we need to use this formula? How come about this? Since we are looking for weight at the what? Altitude. For weight at the altitude, this is the formula we use for weight at altitude. Is going to be Gmm over what? Arrow square. No, arrow plus what? H square. In our previous class, we discussed about this. But if you check this formula, we don't have some of the parameters here from the question. Like the mass of the Earth is not in the question. The mass of the body, the mass of the missile is not in the question. Yeah, I think these two are not in the question. The constant, these are the constant. The constants in parameter, they are not from the question. But if you know it, if you equate it right here, you might get similar answer, something like that. Okay, but this is the actual word formula to use. All right, how come about this formula? Now, how do we derive this formula? We know that for the Earth's surface, that is what? Earth naught, that Gmm over what? Arrow square. This is from the what? Earth surface is the same thing as what? F naught arrow square equals to what? Gmm. Let's call this equation 1. Now, above the ground level at altitude, So at altitude is going to be F equals to what? GMM over what? Arrow plus what? H raised to the power of 2. And let us say arrow plus H, let us equate it with a variable, let's call it D raised to the power of 2. Where D is equals to what? Arrow plus what? H. So therefore, from this equation, I can say that what? FD square is equals to what? GMM. So let's call this equation what? 2. Equation 2. All right, see from this equation, we have something that is constant right here. This is constant, this is constant. So if this is equals to this and this is equals to this, I can equally say that this is equals to this. So therefore, FD square is equals to what? F naught arrow square. And I'm looking for what? Weight above the what? Ground level. That is at the altitude, which is what? F. So if I make this guy subject formula, F is equals to what? F naught arrow square over what? D square. So this is the what? Equation. See, this equation and this one, they're actually the same thing. They're actually the same thing. Actually what? The same thing. All right, we are using this formula or this one. They are the same thing. So from this equation, so if I say F is equals to what? F naught over what? D over arrow raised to the power of what? 2. And what is D? D is what? Arrow plus H. Arrow plus H or H plus arrow. That means D is equals to what? 1.28 times 10 raised to the power of 6 meter. So therefore, F is equals to what? F naught, that means weight on Earth, which is what? 400 over what? D. D is what? 1.28 times 10 raised to the power of what? 6. Is it going to be 6? No, it's going to be 7. Raised to the power of 7 all over what? Radius. Radius is what? 6.40 times 10 raised to the power of 6 or bracket square. Now, if you do this, you are going to arrive at the weights at this altitude is equals to what? 400 Newton. Ladies and gentlemen, we have come to the end of this episode. Please subscribe to my YouTube channel. Thank you and God bless you.